Here we have a SAT math problem. Okay, let's go to the question. In the xy plane above, the parabola y equals to negative kx square positive 1 intersects the x and y axis at the points A, B, and C. If triangle ABC is an equilateral triangle, what is the value of k? Okay, in the given equation of parabola, we have to get the value of the constant k over here. To get the value of this constant k, we need a point on the parabola. Once we get a point on the parabola, we can plug in that point into this equation and get the value of the constant k over here. And in the given equation of parabola, this positive 1 represents the y-intercept of the parabola. Okay, here in the given figure, the point B over here represents the y-intercept of the parabola. Since this positive 1 represents y-intercept, we have this value 1 on the y-axis over here at the point B. And we can write this one as a point that is 0, 1. So this is the y-intercept of the parabola. And also we have this point on the parabola. Okay, here we may think we can plug in this point into this equation and get the value of constant k. No, it's not possible, because when I plug in this point into this equation, what will happen? So I have to plug in this x coordinate 0 for x over here and y coordinate 1 for y over here. When I plug in the x coordinate 0 for x over here, so 0 square is 0. When 0 is multiplied by k, so it will also become 0. So k will vanish and we will not be able to get the value for the constant k using this particular point 0, 1 on the parabola. So for that we have to get some other point on the parabola. So particularly A or C. Actually A and C are the two x-intercepts of the parabola. So I can choose either point A or point C to get the value of the constant k in this equation. Okay, for that we need the points A or C. What do we have to do for that? Let's consider an important stuff over here. So in this xy plane, always the angle between the x-axis and y-axis is a right angle. Now, the line segment OB over here represents the height of the triangle ABC, because it's a vertical line drawn from one of the vertices B to the opposite side of the triangle AC, and also this line segment OB is perpendicular to the side of the triangle AC. So we can consider this OB as the height of the triangle over here. And also triangle ABC as an equilateral triangle. So all the three sides of this triangle are equal. Then the side AB and BC are also equal. So in this triangle, we have the height OB between the two equal sides AB and BC. In a triangle, whenever we have the height between the two equal sides, then the height will bisect the interior angle over here, and also the height will divide this AC into two equal parts. That is, the height OB will bisect this side AC also. Okay, now let me assume the length of the side AC over here as 2x. Since this OB bisects the side AC of the triangle, then the length of this OA will be x, the length of this OC also will be x. And since it's an equilateral triangle, the measure of each interior angle will be 60 degrees. So here also we'll have 60 degrees, and this angle will be bisected. That is, will be divided into two equal parts by the height of the triangle OB. Then we'll have 30-degree angle measure over here, 30-degree angle measure over here. Now let's consider the right triangle we have over here, OBC. In this right triangle OBC, we have 90-degree angle measure over here. Here we have 30 degrees, and what should be the angle measure over here? It has to be 60 degrees. So because in any triangle, three interior angles will add up to 180 degrees. So 30 positive 60, 90, 90 positive 90, 180 degrees. And also it is a special right triangle, that is 30, 60, 90 special right triangle. In a 30, 60, 90 special right triangle, so the shortest leg is the side which is opposite to the smallest angle measure. Here OC is the side which is opposite to the smallest angle measure, 30 degrees. So this is the shortest leg. Usually we assume the shortest leg of the 30, 60, 90 special right triangle as x. Already we have x over here, which represents the length of the shortest leg OC. Now to get the length of the next longer leg, that is the side which is opposite to the interior angle measure 60 degree, what we have to do is we have to multiply the length of the shortest leg x by square root of 3. Then the length of this line segment OB is x times square root of 3. So this is the next longer leg of this right triangle. And the hypotenuse, the length of the hypotenuse has to be 2 times the length of the shortest leg, that is 2x. Already we have 2x over here, and this one also must be 2x, because it's an equilateral triangle. All the three sides will be equal in length. Okay, here we have the height of the triangle OB. So its length is x times square root of 3. So here we have the value 1, and here we have origin. So what is the length of OB from this value? That is clearly 1. Here we got the height of the triangle in two ways. One is in terms of x, and other one is as a numerical value. So in terms of x, we got the height of the triangle OB as x times square root of 3. In terms of a numerical value, the height of the triangle is just 1. So x times square root of 3 and 1 must be equal because both of them represent the height of the triangle OB. Okay, now let's solve for x in this equation. For that, we have to divide both sides of this equation by square root of 3. Then the square root of 3 will cancel out. Then I'm getting x equals to 1 over square root of 3. Okay, here this x represents the length of the line segment OC over here. Then this value of x 1 over square root of 3 we have the points over here. Then we can mark the x-intercept of the parabola C with this value of x 1 over square root of 3. That is 1 over square root of 3 comma 0. Okay, here I got a point on the parabola, that is the x-intercept 1 over square root of 3 comma 0. Now we can plug in this point into this equation to get the value of the constant k. Okay, for that we have to plug in this exponent 1 over square root of 3 for x over here and this y exponent 0 for y over here. Then let me do it. We get 0 equals to negative k times 1 over square root of 3 the whole square positive 1. 0 equals to negative k times. Okay, here we have exponent for a fraction. So this exponent can be taken for numerator and denominator separately. When I take this exponent 2 for 1, it will be 1 square. 1 square is just 1. When I take this exponent 2 for the square root of 3, it will be square root of 3 the whole square. Square root of 3 the whole square is just 3, positive 1. Okay, 0 equals to, when I multiply this negative k and 1 over 3, I am getting negative k over 3. That is, I multiply this negative k and numerator 1. Then we can write this positive 1. Let me add k over 3 to both sides of this equation. Let me do it. When I do so, this negative value, positive value will cancel out. On the left side, when I combine this 0 and positive k over 3, I am getting k over 3. On the right side, we have 1. Our aim is to get the value of k. So for that, we have to get rid of the denominator 3 over here. Let me multiply both sides of this equation by 3. Then this 3 will cancel out. I'm getting k on the left side. On the right side, 1 times 3 is 3. Okay, here I got the value of k. The value of k is 3.